Hello maths fans! Today we're looking at the language of algebra. So the words that we might use in algebra that we need to be able to recognise and understand the meaning of. So let's go through them. It's going to be a look at the first word, and that is numeral. And numeral is just a kind of another way of saying number, really. So 2, 5, 0, decimals, fractions, they're all numerals. They're all numbers that we might use in algebra. That's our first word, one down. Next word you might need to know is a variable. And a variable is a number that we don't know yet. So here's the slight difference here. We've got a numeral is a known number, and a variable is an unknown number. Now we usually write down variables as a letter. Okay, so when you see X, Y, N, A, B, whatever it might be, those are variables because they could be different numbers at different times. Until we know them, they are unknown numbers and they are variables. Okay? Example there, the height of a building, we might represent it as H. Until we know it, we've got this letter H there. Next word we're going to look at is expressions. Now, expressions are an algebraic form made up of numerals, variables, and possibly some operation signs. So squares, roots, divide, times, add, subtract. So for example, 3n or 3 brackets y minus root 7 or minus 5 divided by all of 4 plus t. They are all expressions. Okay, just a collection of numerals, variables, and some maths operations. Now, expressions, we usually consider them as comparing them with equations. So, equations are when we have an equals, equals. So, as soon as there's an equals, it is no longer an expression, it is an equation. So there's the difference between the two. Expressions are collections of the letters and the numbers and some operations, whereas an equation has those collections of letters, numbers, operations with an equals. As soon as there's an equals, we're talking about an equation now, or maybe even a formula. So there we go. We've got numerals, that's just numbers. Variables, that's generally the letters. Expressions, collections of numerals and variables, and then equations, collections of numerals and variables, then there's an equals sign. All right. Next few that we might want to know is terms. Okay. Terms are all of the parts of an expression or an equation. Now, what do I mean like that? Let's have a look at this example down here. So, in 2x plus 5y subtract 4, there are 3 terms. 2x is a term, 5y is a term, minus 4 is a term, okay? So we've got 3 terms in that one. They are the parts of an expression or an equation. Let's look at another one. We've got minus a equals 2b plus c. Minus a is a term, 2b is a term, and c is a term. All right, they're just the parts of those expressions and equations. On we go. A few more to learn, and that is like terms. So when we've got terms, some of them we classify as like terms, ones we can collect together. So for example, 2x and minus 5x are like terms. They're both x's. And we could collect them together to make 2x minus 5x, that would be minus 3x. So if we can collect them together, they are like terms. xy squared and 4xy squared, they're also like terms because they are multiples of xy squared. Minus 3 and 6, they're like terms. They are both what we call constants, which we'll come to in a sec. They're both numbers, just numbers. So we can collect them together. 3x and 4 are not like terms. We can't collect them together because they're not both x's or both constants. Similarly, 5x and 2x squared, we treat those differently. The squareds cannot be collected with the just x's. And 4x, y, and x, again, unlike terms, because this one has a y variable. So the rule is, things are like terms if they have exactly the same combination of the variables. So here we just had x's. Here, just xy squareds. Here, no x's. Here, they were not the same. This one had a different variable. This one didn't have a variable at all. Hopefully that makes some sense. So we collect like terms when they are exactly the same combination of variables. Okay, a constant term is basically just a number. So in here, 7 is the constant. In here, -5 and 4 are the constants. And in here, there's no constants. This one, there are no constants. There is no just numeral on their own. So let's just read the proper definition here. A constant term is any term without a variable that does not have a variable attached to it. So if you've just got a loose 5, a loose 7, a loose 4, they're what we call constants. They don't change as the variables change. And our last bit of language that we're going to look at here is a coefficient. Coefficient, okay? And this is basically the number in front of a variable. For example, here we have 3x minus 4, and we can say that 3 is the coefficient of x. It's the number in front of it. It's the one that's attached to it. Okay, so 3 is the coefficient of x in this one. Here, -8 is the coefficient of k, and here we could say 1 is the coefficient of x. We don't write the 1, but we know there is 1x. Okay, so those are coefficients, the numbers in front of the letters. All right, let's put some of that language into practice. So here we have a very long thingy. I'm not going to say what it is, because that's going to be one of the questions. But here are 5 questions. Here are 5 questions, and I would like you to pause the video now, see if you can answer those 5, and then I'll give you some answers to these in a moment. So pause, have a go, see which ones you understand, and then we'll go through them in a sec. All right, let's see some answers for this one then. So, is it an expression or an equation? Well, there's no equals, so it is an expression. Okay, number 2, the constant. Well, the constant is 8, because it's the only one without a variable attached. The coefficient of y, the number in front of y, is 3. The like terms. Well, the only like terms in this one are the x squareds. So we've got the 9x squared, and we've got the -2x squared. They are the like terms. So we could collect them together, and we could do 9x squared minus 2x squared is 7x squared, if we wanted to simplify that expression. And how many terms are there? Well, at the moment, there's 1, 2, 3, 4, 5. Each of those are terms. So there are 5 terms in that expression. All right, one last little question, or not a little question. We've got several parts to this. And again, I recommend pausing, having a go at this yourself, and then I'll go through the answers, see what we've understood. So pause the video now. And here we go with the answers. So we're going for true and false statements. Z plus 9 is an equation. That is false. And we need to correct this now, so it shouldn't be an equation, it should be an expression. Okay, part B. 3t plus 3 is an expression. True, yes it is, it's an expression. C equals 8 minus 1/5 of p. It's got an equals, it is an equation. True. K equals 4 plus 5v. It's not an expression, that's false. It is an equation. 5p plus 5y minus 5 has 5 terms. False. It has 3 terms. F, the coefficient of x in 2x minus 4y plus 7 is 2. That is true. The number in front of the x is 2. The coefficient of y in 3x minus 2y minus 4 is 2. No, that's false. And the little tiny thing here is it's actually, you've got to keep that minus in there. So negative 2 is the coefficient here. H, the constant term in 5a plus b minus 4 is 4. Again, that's false. It's negative 4. The correct answer is it's negative 4. And lastly, the constant term in 7 plus 3s plus t is 1. No, that's rubbish. The constant is 7, the only number with no variable next to it. All right, hopefully that's got you thinking about the language that we're using there in algebra. Thanks for watching.